to the Modelithics Library QuickStart for Keysight ADS. This QuickStart will give you an introduction to the Modelithics library and an overview of the many model features. A quick background of Modelithics: we provide the most comprehensive simulation model library for RF, microwave, and millimeter wave devices. Our premier product is the Modelithics Complete Library. We also offer precision, measurement, and custom modeling services. Modelithics models are not the same as ideal component or S-parameter models. They are measurement-based equivalent circuit models for commercial parts from the most popular component vendors. The models simulate parasitic effects and offer advanced scaling capability of parameters such as substrate properties, pad dimensions, and part value, as well as temperature and bias dependency for nonlinear active device models. This allows for powerful tuning and optimization of your design. All models are developed using a consistent process and are engineered for highest accuracy. In this video, we will be using Keysight Advanced Design System version 2016.01, along with the Modelithics Complete Library version 16. In general, recent versions of either software package will work similarly as to how it is shown in this video. Also, depending on the particular Modelithics library you have installed, you may see different parts listed in the ADS palette. We will assume you have the Modelithics library installed and the license correctly set up. So let's start ADS and begin with loading the models into your workspace. To make it easier to add Modelithics libraries to your workspaces, we recommend adding them to your favorites list in ADS. To do so, click on Design Kits, Manage Favorite Design Kits. Then click Add Library Definition File. Browse to the C Modelithics Library folder, and then choose the library that you want to add to the favorites list. This is the CLR library, and you're going to select the lib.defs file and hit Open. And click Yes to add this to your list. Repeat those steps for all of the libraries that you want to have access to in this particular workspace. You can see here, this workspace now has the CLR library, passive components, nonlinear diodes, nonlinear transistors, SLC, system level components, the S-parameter model library, the Select Plus library, and the substrate library. You don't have to add all of them to every workspace, just whatever you'll be using in your design. Now, when you open a new schematic to start a design, you will see all the different libraries and different components available for use in your schematic. Let's talk about the models in a little bit more detail. With all of these parts to choose from, how do you decide which component to use in your schematic? Well, if you already know the vendor and part number of the part that you want to use, you can choose it from the list by first going to the vendor and then going to the type of part that you want to add. Then you're going to see the various models of that type that are in the library. If you hover over the different icons, you will see the vendor part number included that is represented by that model. So this will help you make sure that you're getting the right part number that you want to try out in your schematic. If you don't already know what to use in your schematic, there's a very useful table on the Modelithics website to help you decide. If you go to the Modelithics website, click on Products, Complete Library. If you scroll down on the Products page, you will come to a table that contains all of the parts and vendors listed in the Modelithics Complete Library. This table allows you to sort and narrow down your selection in many different ways. So this helps you select the part that you want to use that's available in the Modelithics library. It includes things such as the vendor part number, the Modelithics model number, the component size, the type of component, the max frequency validation. For some of the active models, there's a power out column, and it also lets you know what part values are contained in that model. And if you scroll over, there's a features column which lets you know what Modelithics model features are contained in that particular model. And there's a legend for what those codes mean at the bottom of the website. Let's put a Modelithics model into our schematic so we can explore the advanced model features. Here we have a capacitor model, and you can already see that it has quite a few extra parameters than what you're used to seeing with the built-in model. If you click into the model, you'll see even more. First, you'll see the capacitance value. In general, models in the CLR library represent an entire part series. In this particular model, this capacitor can vary from 0.1 to 100 picofarads, all within the same model. So you can change or tune or optimize the capacitance value. Then there's a substrate property. This can be a definition that you have already set in your schematic for a particular substrate, or you could add individual substrate properties down here. The sim mode is a simulation mode parameter. The default is 0, which means it's representing the full parasitic model, which includes pad and substrate parasitics. The other options are Sim Mode 1, which will make the model simulate as an ideal model. Sim Mode 2 is the same as Sim Mode 0, however it removes the parasitic effect of the pads. And there are several reasons why this feature has been added. One reason is if you have pad dimensions that are not included in the pad scaling range of the model. Another reason is if you're doing EM co-simulation and you've already simulated the pads in the electromagnetic simulation, you can remove the parasitic effect from the model so that it is not counted twice. Sim Mode 3 is a fairly new simulation mode, and this actually removes the parasitics of the pads and the parasitics of the substrate. However, you're still left with the internal parasitics of the component. The pad mode is a feature that relates only to the layout. It has to do with whether the pads are visible or not visible in the layout, and there's information about this feature in the user manual. The tolerance parameter allows you to do the statistical analysis, and here is the pad width, length, and gap, which gives you the pad scaling capability, and each of those has a dimension range of which they are scalable. This is the orientation option. This is available for many of the capacitor models in the CLR library. It relates to the physical orientation of the part on the substrate, so it could be either horizontal or vertical. In ADS, you will have a discrete optimization option, and this will allow you to do optimization based on available vendor part values, whereas the default optimization mode is continuous. One very special thing to know about Modelithics models is that each model has a very detailed model datasheet, which gives you a lot of information about the part and the model. If you're in the Model Parameters window, you can click on Help to access the datasheet. So here is the datasheet for the capacitor that we had in our schematic. As you can see, there's a summary of features that are contained in the model, including the validation range, the substrate scalability range, and all of the scalability features that are available. It tells you which vendor part number the model represents, and then it gives you some model to measurement comparisons. And this is a very interesting plot. This is showing a single part value. This is a 1.2 picofarad capacitor being simulated on 3 different substrates. So you can see why the substrate scalability in particular is a very important feature when you're dealing with high frequency designs. On the next page, there's some more detail about technical parts of the model, and there's a table which indicates the capacitor values included in the model. There's a small graphic showing the land pattern footprint and the dimensions, including where the reference planes are, and this is with sim mode equals 0. Some notes about the model parameters, and then some more model to measurement comparisons. To help with setting up your schematic and using the extra features of the models, Modelithics has developed many example projects to help you get started and to see how some of the features work. To find the examples, go to the C Modelithics Examples for Keysight ADS folder, and each example is then grouped by the type of model. In this example, we're showing a single capacitor model. There's 3 different values, a 1.1 picofarad, a 10 picofarad, and a 100 picofarad. The 3 values are then shown on 2 different substrates. So as you can see, the important parts of this schematic are the S parameter sweep, of course, and especially the substrate definition. So all of the models on the left are referencing M sub 1, which is a FR4 with 5 mil thickness. The 3 capacitors on the right are referencing M sub 2, which is a Rogers 4350B substrate with 30 mil thickness. Let's simulate this example project. The top 2 plots here show S11 and S21 for the 3 different capacitor values on the 5 mil substrate. The bottom 2 show S11 and S21 of the 3 capacitor values on the 30 mil substrate. You can see that there's a significant difference in the response of the part depending on the substrate properties. There are many different example projects that you can take a look at. For some of the active model examples, it's really helpful in how to set up certain test benches and how to set up the properties of the model, including voltage inputs. So these examples are very useful if you're getting started. For additional assistance, many resources can be found on the Modelithics website. On the literature page, there are many app notes, papers, presentations, and more. When applicable, an example project associated with the paper can be downloaded as well. On the support page, you can find supported simulator details, diagnostic tools, and more. There's also a frequently asked questions area to address common inquiries. If you have any additional questions or comments, please email us at support@modelithics.com. Our goal is to help you achieve fast design success, and your feedback is very valuable to us.